So in this video, I'll discuss the valence shell electron-pair repulsion theory or the VSEPR. So sinasabi ng theory na to na yung resulting geometry ng molecule should be based on the minimization of the electron-pair repulsions around the central atom. Okay? So by the way, meron tayong iba't ibang parts ng molecule. So meron tayong central atom right here. Meron tayong mga ligands. Okay? Yun yung mga atoms na nakakabit dun sa central atom. So yung mga ligands nyo, sa iisang atom lang sila naka-connect. Okay? So meron din tayong mga bonding pairs. Yun yung mga bonds between the ligand and the central atom. And meron tayong mga lone pairs. Pwedeng magkaroon ng lone pair ang inyong central atom. Pwede rin magkaroon ng lone pair ang inyong mga ligands. Okay? So electron pairs ang tawag sa mga bonding and lone pairs. So meron tayong dalawang types actually, bonding pair and lone pair. Okay? So yung mga lone pairs, mas dispersed sila kaysa sa bonding pair. So yung repulsion due to the lone pair is greater than that of the bonding pair. Okay? So in this topic, magpo-focus lang tayo sa single-centered molecules. Okay? Ibig sabihin, isang atom lang yung kanyang center. Pwede kasi tayo magkaroon ng molecules na maraming atoms yung center niya, multiple atom centers. So focus lang tayo sa single-centered atoms dito sa Chem 18. Okay? So for the molecule types, we will designate A as the central atom, X as the bonding pairs, and E as the lone pairs. Okay? So start tayo sa isang electron pair lang. So yung molecule nyo, isa lang ang electron pair. So kapag ang subtype niya ay AX, ibig sabihin may isa siyang central atom at isang ligand. So may isa siyang bonding pair. So the electron pair geometry should be linear and the molecular geometry is also linear. So electron pair geometry is the geometry formed by all electron pairs regardless kung siya ay bonding or lone pair. Kapag ka molecular geometry, yan yung geometry formed by the bonding pairs only. Okay? So kapag molecular geometry, bonding pairs lang yung kino-consider. Kapag electron pair geometry, lahat ng electron pairs. Kasama doon yung lone pair. Okay? So makikita nyo yung molecule nyo ganito ang itsura. Linear. So linear yung bond between the central atom and the ligand. Okay? So kapag may dalawa naman tayong electron pair, pwede tayong magkaroon ng dalawang ligand or yung subtype natin pwedeng isang ligand, isang lone pair. Although pareho pa rin silang linear kapag electron pair geometry kasi 180 degrees yung mapo-form na angle between the two electron pairs. So, the molecular geometry is linear kapag AX2. So, makikita nyo ganyan. 180 degrees yung angle between the two ligands. Kapag linear naman, 180 degrees pa rin pero it's between the bonding and the electron pair. Okay? So, kapag molecular geometry, ito lang yung geometry na kinoconsider natin. Yung geometry formed by the bond between the central atom and the ligand. Okay? So, for 3 electron pairs, meron tayong dalawang subtype or tatlo. Nandito yan. Okay? So, AX3, ibig sabihin tatlo yung ating bonding pairs. So, ang electron pair geometry niya ay trigonal planar. And trigonal planar din yung makikita nyong molecular geometry. So, kapag trigonal planar, ganito yung tsura niya. And the angle between the ligands is 120 degrees. So, exactly 120 degrees. Okay? So, yan yung geometry na na-form to minimize the electron-electron repulsion between the bonding pairs. So, the next one is AX2E. Ibig sabihin, dalawa yung bonding pairs, isa lang yung lone pair. So, trigonal planar pa rin yung electron pair geometry niya, pero yung molecular geometry niya ay bent. Kasi, ito lang yung kinoconsider again sa molecular geometry, pero kapag electron pair geometry, kasama yung lone pair. So, makikita nyo, mas malaki yung angle formed by the lone pair and the bonding pair. Kasi, again, mas dispersed ang ating lone pair. Mas malaki yung nasasakop niyang space kaysa sa bonding pair. Kasi ang bonding pair natin ay constrained lang dun sa wave functions ng dalawang atom, yung ligand and central atom. So, more than 120 degrees yung na-form na angle between the electron pair or the lone pair and the bonding pair. Pero between bonding pairs, it's less than 120 degrees. Siyempre, bumababa yung angle between the bonding pairs to accommodate the lone pair. Okay? So, another type is AXE2. Siyempre, isa na lang yung bonding pair nito, dalawa na yung lone pair. So, linear na lang yung makikita nyong molecular geometry. Although, trigonal planar pa din yung ating electron pair geometry. Okay? So, the angle between this, okay, actually is less than 120 degrees kasi, again, mas dispersed yung ating mga lone pair. So, mas malaki yung space na nasasakop nila and therefore, mas maliit yung angle na na-form between the lone pair and the bonding pair. Okay? So, punta naman tayo dun sa molecule na may 4 na electron pairs. So, meron tayong 4 subtypes. Yung isang subtype ay lahat ng kanyang electron pair ay bonding pair. So, kung AX4, the electron pair geometry is tetrahedral and the molecular geometry is also tetrahedral kasi yung na-form na geometry ng ating 4 na ligand ay tetrahedra. So the angle is 109.5 degrees. Kahit sinong kahit sinong ligand yan in between any of the four ligands. Okay? So, kapag ka naman AX3E, okay? Tetrahedral pa rin yung electron pair geometry, although trigonal pyramidal na lang yung ating molecular geometry. Okay? Kasi ito na yung na-form na geometry between the bonding pairs. So, the angle formed between the lone pair and the bonding pair is greater than 109.5 degrees due to the dispersion or the greater dispersion of your lone pair, tapos less than 109.5 na yung na-form between bonding pairs. Okay? So, for the next one, we have AX2E2. Tetrahedral pa din yung na-form niyang electron pair geometry, pero bent na yung kanyang molecular geometry due to this. Okay? So, yung mga bonding pairs, bent na yung shape na na-form. So, again, greater than 109.5 in geometry, okay, na na-form between the lone pair and the bonding pair. So, between bonding pairs, less than 109.5 na siya. So, finally, we have AX-E3. So, that's tetrahedral pa rin, pero linear na siya kasi isa na lang yung ligand or isa na lang yung bonding pair. Okay? So, let's proceed to molecules with 5 electron pairs. So, kapag lahat ng electron pairs na yon ay bonding pairs, we have AX5. So, the electron pair geometry and molecular geometry are both trigonal bipyramidal. So, sa trigonal bipyramidal, meron tayong dalawang parts. Meron tayong axial na ligands, meron din tayong equatorial na ligands. So, yung axial ligands, sila yung ligands na 180 degrees away from each other. Yung mga equatorial ligands, sila yung mga 120 degrees away from each other. So, the angle formed between an equatorial bond and an axial bond is 90 degrees. So, makikita nyo dito yung 90 degrees. Okay? So, this is actually the 180. Okay? 180 degrees. Tapos 120 degrees yung na-form na angle between equatorial bonds. Okay? So, mas mahaba yung mga axial bonds. Okay? Mas malayo yung mga axial ligands kaysa sa equatorial ligands kasi tatlo yung equatorial ligands mo. So, mas mataas yung electron density dyan sa equatorial position. So, since mataas yung electron density, nare-repel nung tatlong ligands na to yung mga axial ligands. Okay? Kasi meron din silang mga electron clouds. So, since masyadong maraming electron clouds between those ligands, okay, lumalaki yung bond length. Okay? Bumahaba yung ating mga axial bonds. Okay? So, punta naman tayo dun sa AX4E. So, sa AX4E, ganun pa rin yung ating electron pair geometry, trigonal bipyramidal, but the molecular geometry is C. So, ang natatanggal natin ay yung equatorial bond. Okay? Kasi, kapag tinanggal mo yung axial bond, ang iba mapo-form mong geometry. Ang mapo-form mong geometry doon ay trigonal pyramidal. Pero, ang mangyayari, yung iyong lone pair, mag-interact siya sa tatlong equatorial bonds, which is more unstable. Dito, pinaka nag-interact lang siya sa dalawang axial bonds. So, kung pipili yung iyong molecule kung anong geometry yung less yung electron-electron repulsion, ito na yung geometry na yun for AX4E. Okay? So, the next one is AX3E2. So, that's trigonal, bipyramidal, or T-shape kapag molecular geometry kasi T-shape yung na-form ng ating mga bonding pairs. So, makikita nyo sa equatorial position ulit na wala yung ating bonding pair, naging lone pair siya kasi yung T-shape ay mas stable kaysa kapag yung axial bonds yung tinanggal mo. Okay? So, yan yung mas stable na position or na geometry for this molecule type. Okay? So, finally, we have AX2E3. So, that's trigonal bipyramidal. Okay? So, another equatorial bond yung papalitan natin ng lone pair kasi mas okay yon dahil 180 degrees yung distance between the two axial bonds. So, 120 degrees yung angle naman formed by each lone pair. So, malaking angle yon. So, mas stable yung ganitong geometry. Okay? So, the geometry is linear for this molecule type. So, kapag may tatlo kang lone pair at dalawang bonding pair, linear ang iyong molecular geometry. And trigonal bipyramidal yung iyong electron pair geometry. Okay? So now let's proceed to molecules with 6 electron pairs. So kung lahat ng electron pairs na yon ay bonding pairs, we have AX6. So that's octahedral electron pair geometry and octahedral din ang kanyang molecular geometry. So makikita natin ganito yung itsura niya. Octahedral yung positions ng mga ligands with respect to the central atom. Tapos 90 degrees yung angle between the two nearest bonding pairs. Okay? So sa AX5E naman, kung yung isa ay magiging lone pair, magkakaroon tayo ng octahedral pa din na electron pair geometry, pero yung molecular geometry natin ay square pyramidal. So square yung base, tapos pyramidal yung yung bottom na part. Okay? So nagpo-form siya ng parang square pyramid. Okay? Yung pyramid na square yung base. Okay? So ganyan yung magiging parang geometry natin. Tapos, okay? So makikita nyo na yung lone pair na to, tsaka yung bonding pair na to, nagpo-form siya ng angle na more than 90 degrees kasi again, mas dispersed ang ating mga lone pair kaysa bonding pairs. So mag-give way yung ibang bonding pairs, magiging less than 90 degrees yung angle between the two nearest bonding pairs. Okay? So let's proceed to AX4E2. Octahedral pa din, again, yung ating electron pair geometry pero square planar na siya. Nasa opposite side na nung ating central atom yung mga lone pair. Okay? Opposite sides yan. Tapos nandito na yung ating mga bonding pair. So nagpo-form sila ng square planar geometry. So yan yung magiging molecular geometry kapag dalawa yung iyong lone pair at apat yung iyong bonding pair. So let's proceed to AX3E3. Octahedral pa din ang ating electron pair geometry. T-shape na yung ating molecular geometry kasi mawawala na yung isang bonding pair, mapapalitan na siya ng lone pair. So T-shape ito, although ang mangyayari yung angle between the two bonding pairs is less than 90 degrees na because meron na tayong mas dispersed na lone pair na nandito. Okay? Tapos greater than 90 degrees yung angle between the lone pair and bonding pair. Kasi again, mas dispersed ang lone pairs kaysa sa bonding pairs. So finally, we have the AX2E4 molecule type. So dalawa yung bonding pairs, apat yung electron pairs. So octahedral yung electron pair geometry pero linear na lang yung kanyang molecular geometry. So makikita natin dito, yan yung kanyang molecule. May dalawang bonding pairs at 180 degrees yung angle between the bonding pairs. So if we look at the lone pairs, 90 degrees yung angle between the lone pairs. And exactly 90 degrees din yung angle between the lone pair and the bonding pair due to the equilibrium between the charge of the bonding pairs kasi uniform na yung distribution ng charge. So hindi na siya pwedeng mag less than 90 degrees or greater than 90 degrees kasi yan na yung farthest possible angle na pwede. Okay? So here we have some notes on VSEPR. So for number 1, the degree of bonding pair repulsions is less than that of the lone pair repulsions. So makikita natin dito for CH4, this is an AX4 molecule type. Okay? Lahat ng angles between any two ligands dito sa molecule na to ay 109.5 degrees. Pero kapag yung isa ay pinalitan mo ng lone pair, for example dito sa ammonia, which is AX3E molecule type, so greater than 109.5 yung magiging angle between the lone pair and the bonding pair, tapos less than 109.5 na yung magiging angle between two bonding pairs. So nag-give way yung bonding pairs sa lone pairs kasi mas dispersed ang wave function ng lone pairs around the central atom. Okay? So for number 2, bigger ligands means greater repulsion. So kung puro hydrogen lang, for example dito sa methane, okay, uniform yung angle, 109.5. Pero kapag pinalitan mo na ng chlorine, yung isang ligand, nagiging greater than 109.5 yung angle between the chlorine and the hydrogen. Again, mag-give way yung mas maliliit na ligands, so less than 109.5 yung mga angles between the hydrogens. Okay? Kung puro naman chlorine, okay, yung mga ligands, syempre yung angle between the chlorines is greater than 109.5. So mas lalapit yung ibang chlorine dun sa hydrogen. So therefore, the angle between the chlorine and the hydrogen ligands is less than 109.5. So for number 3, multiple bonds means greater repulsion. So makikita natin sa mga examples na pareho silang AX3 molecule type. Dito sa BH3, makikita natin na 120 degrees yung angle between any two adjacent hydrogens na ligand ng inyong molecule. So dito, meron tayong makikitang double bond. So yung double bond, nagpo-form siya ng greater angle with the fluorine, greater than 120 degrees. So yung oxygen and fluorine, mas malaki yung angle nila kaysa sa dalawang fluorine which is less than 120 degrees. Kasi may effect yung ating multiple bond or yung double bond dito. Greater repulsion siya kasi it contains a total of 4 electrons or 2 electron pairs or 2 bonding pairs to be specific. Okay? So next, for the AX5 molecule, the axial bonds are longer than the equatorial bonds. So na-explain ko na ito kanina, greater yung repulsion between the 3 equatorial ligands. So lumalayo yung inyong axial ligand. So humahaba yung bonds ng axial ligands nyo. Okay? Kasi tatlong equatorial ligands yan, yung nakaka-interact ng inyong mga axial ligands. Hindi tulad nitong equatorial ligand na to, actually dalawa lang yung nakaka-interact niya kasi due to the angle which is the 90 degree angle between the axial and the equatorial ligands. Hindi niya masyado nakaka-interact yung kapwa niyang equatorial ligands. So, mas maikli yung mga bonds ng equatorial bonds or equatorial ligands kaysa sa axial ligands. Okay? So, finally, we have the so-called polarity. So, polarity, okay, is obtained when you have a net dipole moment. So, yung mga bonds natin, you can consider that as vectors. Tapos kung yung vectors natin ay nagka-cancel, ibig sabihin yung resulting vector natin ay 0. Ang tawag sa molecule na yun ay non-polar. Pero kapag may resulting vector tayo, ibig sabihin meron tayong net vector, ang tawag doon ay polar, or meron tayong net dipole moment. Okay? So for example, we have water. So yung mga OH bonds niya, meron tayong tinatawag na dipole moment vector. So yung dipole moment vector natin is from the less electronegative to the more electronegative. So alam naman natin na yung OH bond ay polar bond. Okay? So yung mga dipole moment vectors natin hindi nagka-cancel, so nagkakaroon siya ng resulting vector na ganyan. Kasi bent yung ating water. Kung linear yung water natin, magka-cancel yan. Pero since bent siya, magkakaroon tayo ng resulting vector. That is the net dipole moment. So therefore, water is polar. So for carbon dioxide, kung i-compute nyo yung change in the electronegativity of the CO bond, okay, yung difference sa electronegativity ng carbon and oxygen, meron tayong specific value, which makes this carbon-oxygen bond polar. Pero makikita nyo na nagka-cancel yung vectors kasi yung isa ay papunta sa right at yung isa ay papunta sa left. As pareho sila ng magnitude kasi pareho silang CO bonds. So since nagka-cancel ito, non-polar yung magiging resulting net dipole, or zero yung magiging resulting net dipole moment natin. Therefore, carbon dioxide is non-polar. Okay? So, ganun din yung nangyayari sa ating methane. Although yung methane natin ay puro CH bonds, CH is not very polar. So, na-calculate na natin yung kanyang change in electronegativity. Okay? So, that's 0.4. So, yung ating CH bonds ay hindi naman masyadong polar to begin with. So, therefore, non-polar ang methane. Okay? So, for the ammonia, yung NH bond natin ay very polar. So, makikita natin na since trigonal pyramidal yung geometry, hindi nagka-cancel yung mga vectors ng ating NH bond. So, magkakaroon tayo ng net dipole moment. So, therefore, your ammonia or NH3 is a polar molecule. Okay? So, this is my discussion on the valence shell electron-pair repulsion theory. So, pwede na tayong mag-construct ng mga Lewis structures using the concepts of valence bond theory and the VSEPR sa next video. So, see you next video.